Welcome to another video. This will be a quick follow-up regarding my last video. So for the quick return mechanism CATIA V5, I added the angle driven for revolute 2, which is between the frame of the mechanism and the middle crank. Now I will have this removed. You're gonna see that the mechanism will no longer be able to be simulated, and I will go to the prismatic joint and I'm gonna set this to be length driven. So over here I already went and changed the limit to -1000 plus 1000. Now I went back and changed them to the default value, which is -100 in CATIA, positive and negative. This is the same value that is, let's say, the default, as the angle is -360 and 360 degrees. So we're gonna see that with that change we can now simulate the mechanism, but I added previously that -1000 positive 1000 because the length of the upper frame in this case will be 2000 millimeters, as we can see with the measurement tool over here. So now if I added the prismatic joint to control this mechanism, depending on the distance that we set that length driven, we're gonna have the movement of the crank. So we're gonna see that we're gonna have -1000 over here. But if I'm gonna set this animation into a loop, so back and forth, we're gonna see that it will move -1000 millimeters. Afterwards it will return over here. Therefore we need to adjust the limit over here, so we can go either over here on the limit and have this adjusted to be all the way to -1000. So I'm gonna go over here, -1000. Therefore I can go with the slider all the way to the back. We're gonna see that -945 will be that end. We can also move the slider with the cursor. So if you only want to have it move all the way over there, we can have it slide all the way to that section, or we can just measure it and add that value. So depending on how you like to simulate your mechanism, keep in mind that you can also add numerical values, or you can drag that element. And now since we added that -1000, we're going to see that the mechanism will go all the way over here. So it starts rotating, as you can see, the original position all the way over here. Now for the other highest value, if I will go all the way to 1000, you're going to see that the mechanism top element, which is called tool over here within the product tree, will go all the way to -180 in this case. And I can add that as a stop within the simulation. I can have that played. I'm just going to slightly increase that speed so we can see the simulation faster. So as this mechanism is intended, it won't be able to slide all the way over here to the right side, since this lever will always be constrained over here on the crank. Because even if I will remove this prismatic joint to no longer be length driven, and I will go back to the previous angle driven over here, we're gonna see that the crank move even for a full 360 degrees. This slider will only go to the left and then return to this value. Also, when you are thinking about defining DMU Kinematics, for the elements that are driven, so in this case this is angle driven, the most logical attempt is to think about the movement that will be added to the mechanism. And in this case the movement will be done using a motor over here for the crank, which will rotate. Therefore the slider will also go on the top section. Okay, so I wanted to make this follow-up video for the previous quick return mechanism in order to show you how you can also change the movement within the mechanism. So as we saw, we can add either length driven, or we can go with angle driven in this case for the frame and crank. So I hope you find this content useful. I'm going to position a similar video over here to the left and a subscribe button to the right. Thanks for watching.